Hi, this is Dr. Godwin Menir of Homeland Farms. I would like to share my design of a biodigester, and I'm building this device at the site of the future Homeland Farms in Nigeria. The biodigester is a device that is used in breaking down organic wastes using bacteria. This leads to production of essential byproducts such as biogas and a nutrient-rich fertilizer. In the device I'm building right now, this is going to be constructed mainly of concrete and reinforced slabs. You can also build biodigesters with plastic drums and tanks. Alright, so just looking at the diagram, let me start from the bottom. The bottom here is made up of 4-inch reinforced concrete slab. Reinforcement means that you have metal rods there. You form a crisscrossing, maybe squares of metal rods, and then you make a cement, sand, concrete mixture that you then pour and make sure it gets under the metal rods and on top. And then on top of this metal reinforced concrete slab that you've poured down, you now start building the biodigester. In this case, this biodigester is about 4 meters wide this way. Some people may say this is 4 meters long. It's 3 meters deep from top to bottom, but you'll notice that about 1 more meter of block work goes above ground. So it's 3 meters down this way, plus another 1 meter here. So you might say that it has a total depth of 4 meters. Now I'm going to use, or I'm already using 6-inch solid blocks for the walls. So in the current biodigester I'm building, I did about 6 lines of blocks. Each block measures 6 inches by 18 inches by 9 inches high. So this is 6 inches. Then one block is 9 inches high and it's 18 inches wide. These blocks are layered on top of each other and interdigitate with the other lines of block all around the structure. And we use a cement sand mortar for this. Then after 6 layers of blocks, we then pour a concrete ring on top of the block work, in addition to vertical concrete columns that will also be going from all 4 sides of the tank and from the middle of the tank. You notice that there is a wall here that goes up to that same 3 meters approximately. And at this point we pour a transverse concrete beam on top of this wall, and this wall ends at this point. It functions by restraining solid matter mainly to this side of the tank and allow only the fluid to flow over to that side. So we go up about 3 meters, and this is when we emerge above the ground level as shown by this line here. And then we'll continue for another meter, especially because of this component that we have to install at this point. It's installed above ground. Alright, now entering the tank is a 6-inch diameter pipe. This is connected to the drainage of the animal house we are draining. In this case, I'm going to use this for a piggery. So the piggery effluents, the feces of the pigs, the urine, and the water we use in washing the floor twice a day, all will flow through this 6-inch pipe down to about, I'll say approximately 1 meter from the bottom of the tank. It doesn't go completely down to the bottom of the tank unless it will get clogged up by the fecal matter, that is solid fecal matter that is flowing into the tank. Now I've tried to find a way to make sure I have a very tight seal here. This is going to be a 4-inch thick slab of concrete, reinforced concrete again. On top of that, I'm going to pour another 4 inches to 6 inches of concrete to be like a concrete collar, all trying to make sure this pipe never shifts, because if it starts wobbling, then cracks will appear through which the methane gas that we're going to produce here escapes. So that's why I call it a concrete collar. At this point, we will put in manholes. One manhole will go straight into this compartment, while another manhole will go into this compartment. The task here will be to find a way to make sure we have a gas-tight seal once we cover this manhole with the concrete slab. At the moment, I'm thinking of using a rubber pad to seal this opening, and then this is going to be a concrete cover, and these will be rings embedded in the concrete, metal rings that we use in lifting the cover. The same thing is done on this side. At the middle, we'll have a 2-inch diameter plastic pipe through which we hope to channel the gas into this tube. The tube will then conduct the gas to all the devices that will be running off the methane gas. This is a closure device. This represents a closure device, a tap, with which we can turn this off and on. But note that you can't turn this off for too long a time, because there will be pressure build up here, and at some stage the gas might rupture through some part of the tank or find a hole through which it starts leaking out. So this is a temporary closure device. In trying to again make this entry point gas tight, I have angled a pipe through the concrete for a distance of about 12 inches, 20, 25, 30 centimeters, so that there will be more surface area that will be occluded by the concrete. Coming to the right side of the tank, we also have a pipe here. This is going to be a 3-inch diameter pipe. The ends are all open. It's a T shape. It's open here, it's open here, and it's open there. This prevents this pipe from acting as a siphon, because once the fluid starts flowing, at some point it might become a siphon and siphon off all the water down to this level of the tank where the pipe ends. The idea is that broken down material, some of it will float in water or be dissolved in water and will eventually drift over to this side of the tank. And when it gets to the level of this outlet, it flows out. So this end of the pipe will be connected to a 50-gallon tank, which will be half dug into the soil to keep it in position and allow the fluid to drip into it. Again, we'll place a cover here to reduce ingress of flies into the tank, into the 50-gallon drum we're going to place here. Alternatively, we can connect this with a pipe to run to the garden beds or wherever else we want to situate a collecting device. So to recap, we have a biodigester here that is 4 meters long and 4 meters high with 1 meter above ground level. It is 2 meters wide too. I'm using 6-inch solid block cement sand blocks, except for the last layer of blocks where I'll have hollow blocks. Why I'm making them hollow is that after we've woven the metal matrix that we're going to use in pouring the concrete here, I'm going to insert some of those metal components of these rods into the holes and then pour the concrete into the hollow components of the block while I'm also pouring the slab, so it will interdigitate with those holes and hopefully make the top of this biodigester more gas tight, more airtight. Now, before this slab is poured, we are also going to apply a 3-inch thick cement mortar on the walls to plaster the walls. The aim is to use this in making this tank watertight. We don't want the fluid to be absorbed into the soil, because that will reduce the runoff we're getting from this tank here. So 3-inch thick cement plaster, sand cement plaster on the sides of the tank. In terms of function, after construction of this tank, you will normally allow it to cure for about 21 to 28 days. At that time, you will put in a starter of cow dung. I estimate that you might need maybe 4 buckets to start off with. If the animal waste you're going to be putting into this tank is not cow dung, then you will need to use a cow dung starter poured in here before you then fill up the whole tank with water until it starts dripping out here. Certainly the level of the water in the tank or the fluid in the tank should be above the opening of this outlet pipe. The reason why you're using cow dung as a starter when the animal waste is not going to be from cows is that cow dung contains the methanogenic bacteria. These are special bacteria that are found in cow dung that digest the organic material and produce methane gas. You will have a combination of methane gas and carbon dioxide floating here. You might also have other gases like hydrogen sulfide. But you need that cow dung starter here. And then you can then channel in your animal waste, whether it's from chicken or from pigs or any other animal, or goats for that matter. The waste gets digested here and the nutrients get suspended in the fluid here, and you collect it out there at intervals as dictated by the volume of your animal waste. You will need to empty the tank maybe at 3-month intervals or 6-month intervals. You need to empty the tank. You either resuspend all the slurry here and pump it out, or you might use a manual painstaking method to go down and extract the solid component here. And then you either dry everything you collect here, or use the liquid slurry and spray in the farm beds immediately. So either you dry it and package it in containers, or you use the slurry immediately, the resuspended material, and spray it on your garden or farm before planting or after the plants have already been established. Finally, let me just emphasize that products from the biodigester will include methane gas and carbon dioxide and maybe some hydrogen sulfide. You might install a steel, copper, wool filter somewhere along the line to remove the hydrogen sulfide, or you might use it straight, immediately connected to your modified gas stove and used for cooking. You can connect this to a modified Tilly lamp to provide light. If you have a very large biodigester, I believe much larger than this tank, you might run a gas turbine electric generator off the gas you're using. You can compress this gas and use it for cooking. You can also use it for driving farm vehicles, gas powered or gas converted farm vehicles. You also could sell this. So the biodigester is quite an improvement over the normal composting process because it traps the gases within this container, from which you can then tap and collect for the uses that we have already described. That reduces the smell in the environment. It reduces the nuisance of flies and other insects that are attracted by the smell and potential material for them to feast on. It produces a very high quality liquid organic fertilizer. In addition to solid fertilizer, you will collect at regular intervals. This truly helps you in your journey towards having an integrated farm where you try to have zero waste. So you have your animals from which you collect their waste. You use the waste for fertilizing your crops, and then crop produce is fed to the animals. At least some of your crop produce is fed to the animals, and you then go back to the cycle of producing meat and milk and other animal produces, while the wastes come into your biodigester for breakdown and then going back again to your farmland. This illustration is not drawn to scale, but it just gives you an idea of relative proportions. You can build a smaller biodigester, you can build a larger one, but make sure you put in adequate reinforcements, especially if you're making a larger tank. Have an engineer look into your design before you start building. You can change the design you see here. Please share any experiences you have using this or similar design. And that hopefully will help us all in this bid to reduce waste, reduce odor in the farm, prevent pollution of the soil and the waterways, generate some income from these. This is an income stream. Use it for manuring your farm. Really allows you to become organic if you want to use that classification for your farm. It doesn't just mean using your organic fertilizer, it also means other things you do in the farm and synthetic pesticides that you don't use. This will save you money as well as generate some income. Okay, please, I'll appreciate feedback on this. I'll appreciate your experience if you build this, or if you already have one. I'll then sign off at this time. Thanks again for watching. This is Dr. Godwin Meniru from Homeland Farms, Nigeria. Thank you.